Electrical feeder lines are the highways of your electrical system. They carry large amounts of electricity from the source to different parts of your house or building. Think of them as the main branches of a tree, distributing power to smaller branches, which are your circuits. These lines are essential for everything that runs on electricity. They are what allow you to turn on your lights, power your appliances, and use all your electronic devices. Without feeder lines, our modern world would grind to a halt. Just like any critical infrastructure, feeder lines need to be carefully designed and installed. This is where the importance of proper computation comes in. Calculating the electrical feeder lines is not as simple as plugging in a few numbers. It requires a deep understanding of electrical principles and codes. These computations determine the appropriate size and type of wire to use. Why is this so important? Because the size of the wire determines how much electrical current it can safely carry. If the wire is too small for the amount of current flowing through it, it will overheat. Overheating can lead to a number of problems, from melted insulation and short circuits to electrical fires. In a worst-case scenario, this could result in serious injury or even death. Therefore, getting these computations right is not just about efficiency, it's about safety. It's about ensuring that your electrical system operates reliably and without posing a hazard to you or your property. Incorrect computations can set off a chain reaction of problems in your electrical system. The most immediate and obvious consequence is the risk of overheating and fires. However, the repercussions go far beyond this immediate danger. When wires overheat, their lifespan is significantly reduced. This means you may face frequent and costly repairs, or even a complete rewiring of your electrical system. This can be a major inconvenience and a significant financial burden. Moreover, appliances and devices connected to an inadequately wired circuit may not receive the correct voltage. This can lead to poor performance, premature failure of your electronics, and even damage beyond repair. In essence, incorrect computations don't just impact the wires themselves, they affect the entire electrical ecosystem of your house, putting both your safety and your wallet at risk. Let's say you're renovating your kitchen and adding new appliances. You need more power, so you add a new circuit. But instead of calculating the required wire size, you use leftover wire from a previous project. This wire, unfortunately, is too small for the increased load. As a result, the wire starts to overheat whenever you use the new appliances simultaneously. You might notice a burning smell, or the circuit breaker might trip frequently. In a worst-case scenario, the wire could ignite a fire. In another scenario, imagine an office building with insufficient feeder line capacity. As more computers, printers, and other office equipment are added, the electrical system becomes strained. This could lead to frequent power outages, disrupting work, and potentially damaging sensitive electronic equipment. These examples demonstrate how seemingly minor errors in feeder line calculations can have significant and costly real-world consequences. Overheating is one of the most dangerous consequences of incorrect feeder line calculations. When an electrical wire carries more current than it is designed for, it heats up. This heat can melt the insulation surrounding the wire, exposing the bare conductor. Exposed conductors pose a severe risk of electrical shock and fire. They can also come into contact with other conductors, causing a short circuit. Short circuits can be extremely dangerous, potentially leading to explosions and fires. Overheating can occur slowly over time, or it can happen very quickly. Regardless of the speed, it is a serious problem that should never be ignored. Section 6: The silent threat: voltage drop and its impact. Another issue arising from improper feeder line calculations is voltage drop. Voltage drop is the reduction in voltage that occurs as electricity travels along a wire. A certain amount of voltage drop is normal, but excessive voltage drop can cause problems. When the voltage supplied to an appliance or device is too low, it may not function correctly. Motors may run slower, lights may flicker, and electronic equipment may overheat or fail prematurely. In extreme cases, voltage drop can even damage sensitive electronic equipment beyond repair. This is why understanding and accounting for voltage drop is crucial in feeder line calculations, especially for longer distances. Section 7: Efficiency matters: power loss and wasted energy. Incorrect feeder line calculations can also impact the efficiency of your electrical system. When wires are too small, they offer more resistance to the flow of electricity. This increased resistance leads to energy being lost as heat. This wasted energy translates into higher electricity bills. While the amount of energy lost in a single wire might seem insignificant over time, and across an entire electrical system, it can add up to a considerable expense. Therefore, using the correct wire size is not just about safety, it's also about ensuring that your electrical system operates as efficiently as possible. Section 8. Prioritizing safety, preventing electrical mishaps. Preventing the dangers associated with incorrect feeder line calculations begins with understanding the importance of getting it right. This means relying on qualified and licensed electricians to design and install your electrical system. Never attempt to do electrical work yourself unless you are properly trained and qualified. Electricity is unforgiving, and even seemingly minor mistakes can have disastrous consequences. Always prioritize safety when it comes to electricity. Regularly inspect your electrical system for any signs of damage or wear and tear, and address any issues promptly by a qualified professional. Section 9. Ensuring accuracy, best practices and precautions. Several steps can be taken to ensure the accuracy of your feeder line calculations, and in turn, the safety and efficiency of your electrical system. 1. Consult the codes. Always adhere to the latest edition of the National Electrical Code or your local electrical codes. These codes provide specific guidelines for wire sizing, overcurrent protection, and other critical aspects of electrical installations. 2. Accurate load calculations. Accurately calculate the total electrical load for the circuit or system. This involves considering all connected appliances, devices, and equipment, and their respective power consumption. 3. Voltage drop considerations. Account for voltage drop, especially for longer wire runs. Using larger wire sizes or installing conductors in parallel can mitigate excessive voltage drop. 4. Professional expertise. Engage the services of a qualified and licensed electrician for all your electrical work. These professionals possess the knowledge and experience to perform accurate calculations, select appropriate materials, and ensure a safe and compliant installation. 5. Regular inspections. Schedule periodic inspections of your electrical system by a qualified electrician. Regular inspections can help identify and address potential problems before they escalate into safety hazards or costly repairs. By following these precautions and prioritizing safety and accuracy, you can have peace of mind knowing that your electrical system is operating reliably, efficiently, and without posing unnecessary risks.